When the water depth is close to the critical depth in an open channel, a small change in specific energy can induce large changes in water depth, and some ondular flow motion may be observed. Such a motion is called transcritical flow, near critical flow, or ondular flow. And this is illustrated in the relationship between specific energy and water depth. Seminal transcritical ondular flow includes the stationary ondular jump, the ondular bar in translation, and the ondular flow in the barrel of a culvert. A few illustrations follow. The first photograph shows stationary ondular jump in a laboratory channel looking downstream. The next two photographs show an ondular bar in translation. The first one shows the first wave crest of a laboratory ondular bar with a Freud number of 1.1. The second photograph presents the ondular tidal bar of the Chentown River in Hangzhou City in 2014. The next photograph illustrates an ondular flow in a minimum energy loss waterway barrel during a storm. The following datasets document the upstream propagation of an ondular bar in a 12-meter long rectangular channel, highlighting the smooth ondular free surface profile. Importantly, the traditional graph between specific energy and water depth, shown before, is constructed assuming hydrostatic pressure distribution, an assumption that is invalid in ondular flow. In an ondular flow, the pressure gradient is less than hydrostatic beneath a wave crest and greater than hydrostatic beneath a wave trough. A more relevant approach in transcritical and ondular flow is the use of the parametric relationship between the dimensionless momentum and dimensionless energy. When there is a quasi-conservation of energy, the equation of conservation of momentum and energy may be expressed on the relationship between momentum and energy as two branches intersecting at m over dc square equal 1.5 and e over dc equal 1.5, the intersection corresponding to critical flow condition. The two branches of that relationship represent the only possible relationship between momentum and energy in a transcritical flow as long as the equation holds. A typical ondular bar data is shown here for a Freud number of 1.1. The upstream initial flow conditions are shown in red, and the ondular flow data between the first and the fourth wave crest are shown with blue symbols. All the data, as you can see, of this ondular bar are on the parametric curve M versus E, and the quasi-totality of the ondular flow are on the subcritical branch. The concept of transcritical flow, ondular flow, critical flow, and momentum consideration contribute to the basic understanding of advanced open channel hydraulics. These are further discussed in the relevant YouTube video movies, in the same playlist, and in another playlist.